Welcome to the Advisor AI Solutions podcast, where we explore how cutting-edge strategies are transforming businesses, scaling operations, and driving extraordinary growth. I'm your host, Jordan Salvador. Today, I'm joined by Anthony Dent, Principal Engineer at Verdant Structural Engineers and CEO of Verdant Building Products. Anthony is a licensed engineer across the U.S., a LEED accredited professional, and a recognized leader in sustainable and natural building. His work is shaping the future of net zero and carbon neutral building design. Anthony, super privileged to have you here today.
Yeah, thanks for having me on, Jordan.
So here's the bold claim we're exploring today. The path to net zero buildings isn't just about technology. It's actually about rethinking the very materials we build with. You have shared a little bit about green building in the past, the breakthroughs Verdant has achieved. But before we kind of jump into these things, do you mind sharing a little bit about your story and your journey to get to here?
Sure, I'd be happy to. I grew up in Pennsylvania. I went to Penn State University, and I was when I was graduating with an architectural engineering degree, I had learned about straw bale construction, a form of construction where we use full bales as essentially big fuzzy blocks, masonry elements, which form to speak structurally, a ductile inner core between two plaster skins. And there were only a few engineers out in the real world working with this system. And I moved out to California to work under Kevin Donahue's structural engineers. And that's going on 20 years ago now. And Kevin Donahue and I eventually became business partners and started Verdant Structural Engineers. And Kevin just stepped back into retirement. Now Kelsey Holmes Foster and I are keeping it running.
Oh, that's wonderful. So maybe you can share with us and our, myself and our listeners, was there ever a spark that kind of triggered like, all right, this is where I want to be, sustainable sustainable design, like what was that moment for you?
Yeah, good question. I was started learning about all kinds of environmental pursuits when I was in college, and I was getting a structural focused degree in an architectural engineering program, and I was getting a lot of feedback from my professors and elders in the general field that structures really wasn't the best avenue for me if I cared about the environment. Electrical engineering, we could focus on solar panels or energy optimization. And I felt down in my core that was wrong, that there was a place to be thinking about the environment in every field of practice. And in fact, perhaps structural engineering needed the most help. And that lit a bit of a fire underneath me, and that I still do my best to keep burning to this day.
That's awesome. So like, it sounds like where others saw limitations and roadblocks, you basically saw it as a ton of possibility.
Right. And I now understand why that was. For many years, it was easy for us to quantify how much energy a building was using. It's right on your energy bill every month. Whereas the carbon consequences and environmental consequences of the materials that make up our building is a far more tricky science and number to calculate. And it's only until recently, through much effort over decades of folks at the front of the field, that we're able to do now what we call life cycle assessments, where we can compare apples to apples on different materials coming from different manufacturing types, different source materials, and really start to talk in an educated and effective way. And not only talk about it, but make action on it, make policy and make products around good choices dealing with the environmental effects of the materials that build our buildings.
A life cycle assessment. I've never heard of that. Do you mind, unpacking that a little bit?
Sure. And, carbon's the new black. Carbon's the thing we talk about all the time, but there are other consequences of the materials and choices we make in buildings. And the LCAs are life cycle assessments are intended to sum up or sort of give a report card or even like a nutrition label for the environmental effects of a building. But like I said, most of the conversations are around carbon consequence, given the climate crisis that we're in at the moment. And Athena was one of the first programs out there, but now there are many programs. One Click, the Beam tool is a tool that recently came out that really kind of focuses and gives opportunity for people using biogenic materials or bio-based materials. That's something we haven't got into yet, but materials that grow absorb carbon in their cells in their lifetime through photosynthesis. And if you store that carbon effectively, like a high performing building system, you stop that carbon from releasing back into the atmosphere. And that's where you can start storing sun cycle carbon, rather than a lot of the carbon conversations we have around material where we try to just simply do less bad with fossil fuel based carbon materials. And
Okay, that's terrific. So, what kind of materials are you guys working with right now?
yeah, we so Verdant Structural Engineers, we're licensed across the country, and we work on everything from very small residential to mid-rise mixed-use commercial buildings, 4 or 5 stories. And we specialize in these deep green, low carbon, and natural building systems. So we work with low carbon concrete, cement, and concrete. We also work with mass timber, but the things that bring us to these podcasts most, and I think has the big untapped potential and less people working on them, are the straw construction, hemp construction, also known as hempcrete, and the clay construction, adobe or rammed earth, monolithic adobe, super adobe, compressed earth blocks.
Nice. I love that. Okay, so Anthony, so many people they assume sustainable design is always more expensive or less practical, even. Um, from your experience, what do you think the biggest myth about green building that needs to be challenged is?
Uh, I think the biggest myth is that it can't be high performing. And for example, we are there are a lot of superpowers that these materials have, to use maybe a funny term, that aren't exactly the way that we measure strength right now in our buildings, but it doesn't mean that they're not high performing. And it just means that every material has its right use case, every project has its right material choices, and you just need to find that when straw, when hemp, when clay is right for your building, and being on the cutting edge of how people are innovating with them. When I first started with Kevin Donahue, going on 20 years ago, full bale straw, mostly laid flat, mostly with wall systems that were 24 inches thick and another 2 inches of plaster on the exterior, were the only ways we could really use straw. And something I haven't mentioned about straw right now, it's a ubiquitously available agricultural byproduct. This isn't something we need to make a new chemistry for. This isn't an industry that we need to set out. It's already there. We're already growing this plant in massive amounts. But the 2-foot wide walls, it's pretty common to get looked at a little cross-eyed or funny from every single contractor who steps on that job site. How are you making this pencil out? Why are we doing this? And I recently got a small business innovation research grant from the EPA to optimize straw as an insulator in a composite with a bio-based binder. And that's my second company, Verdant Building Products, where we're thinning wall systems out because we're achieving the same performance as conventional insulations. And when you are meeting performance, that's when you meet the same wall thickness requirements. And that's an example of an innovation in straw that is allowing these materials to fit the mold of what builders, what designers are used to. And that's the trajectory we're on. I feel as a community, we work on the outer edges of alternative construction and work with these wider wall systems or these maybe difficult to mix adobe or cob mixes. But our pursuit is to innovate and get more permits, show more examples so that products can get involved and we can normalize the system. And I'm really proud to say that there are a lot of examples now of ways that conventional architects, conventional clients, conventional builders can be looking at these materials that are far different than what they were when I first started.
Right. No, that's tremendous. Being able first to recognize a very widely found byproduct and be able to convert that essentially to an optimized building material that's just as good or if not better than things that are already being used in practice.
Yeah, and another big step that happened along the way is we were out just trying to help people as structural engineers get permits for buildings using what we consider to be the good stuff. But we found that we needed some research to back that up, and so we developed a number of relationships with universities across California, and now somewhat across the country. And we ended up with this backing of research that we realized we were able to approach the International Code Council and actually start making building code changes with these. And so another change that happens, not just product optimization and approach optimization, but building code advancements. In the appendix of the International Residential Code, I was the lead engineer for the first of its kind hempcrete building code. Kevin Donahue was part of the 3-member task force in the development of the straw appendix. I was also the engineer for the cob or monolithic adobe appendix, and there are others there as well. And these appendices are still just a foot in the door in a bigger process, but they're a big foot in the door.
Right. No, you got to start somewhere, right?
Yeah.
Okay, so Anthony, if you were advising a newer architect or a developer today, what framework or perhaps mental model would you give them to start designing for carbon neutrality?
Yeah, it's a good question. I talk to a lot of different architecture groups, more conventionally focused architecture group now, because I mentioned our work with permit acquisition, and then with research, and then with code development, and we've become attractive as a firm to help other product companies innovate and understand how they relate to the building code, permit acquisition, and just structural use in general. So I'm somewhat on the cutting edge of like how these products and how these even systems are becoming more mainstream and usable. So the first thing I do when I talk to a new architect or designer is understand who their clientele are, their scope of buildings, how far do they want to push, and there's just with blown cellulose and a really low carbon concrete mix below your house, you can reduce the embodied carbon in your building, embodied carbon being the carbon embodied in the materials, where we use the term operational carbon for the carbon associated with operating the building, the HVAC system. But you can, just with simple moves like that, not even getting into hemps and straws, you can make such a big difference. And on some level, we're innovating these radical ideas that I think will truly be the building materials of the future, the hemps, the straws, the clays. But in our lifetime, the biggest carbon effects we might have is really focusing on low carbon concrete and just the better blown cellulose options. And I want to mention, the step beyond blown cellulose, company Hempitecture out there making hemp bat replacements. I was just with Tommy up at the Rocky Mountain Natural Building Conference last weekend, and they're making a great product that really fits right in with the way people are used to building right now. But focusing on how far folks are able to push and do, and their budget and where they're putting their money. That's another question. Is we spend so much time looking at, the Verdant panel, it's X amount per square foot, but conventional frames is $10 a square foot a wall, less than that, and then. And we pick that all apart, and we are on track. We're in an early phase. I should say we're in an early phase adoption right now, but when we reach full scale, performance equivalent and cost equivalent is where we'll be. So right now there's a slight surcharge on cost, and that's what I'm talking about here. But when it comes down to it, the cost of the wall system isn't actually a major player in the whole cost of the building. And how are people making choices with their dollar in the buildings allows me, having no judgment about how they're doing it, just really truly understanding it. I can help them understand what options might be most available to them.
Right. So it sounds like education is a big proponent to be able to, provide some of your advice.
Yes. And then some people are drawn to us for this community building aspect. So hempcrete in its form and full bale straw construction and a lot of adobe and cob are traditionally community built. These materials go back millennia. I mean, the full bale goes back to the invention of the baling machine about 150 years ago. But straw and grass construction go back to the beginning of time, human time, and the so there are these site sourced and site manufactured techniques with these materials that can be very natural, not just natural in their physical state, but kind of a natural process of community build, owner builder. And so we support that a lot at our office as well. And it's a lot of the ideas that come from those projects that I think spark the innovation and scalability of these materials. So again, what kind of clients come into the table right now? I have folks that, are just diehard about the Hobbit house, and let's get them that Hobbit house and learn from it. And let's also realize how we can take those clay materials and bio-based materials that are typically associated with Hobbit houses and make the sleekest, most modern looking house. And that's something that's really fun for me, having the same materials being used in buildings that look quite different, because everybody wants to live in, the house that feels best for them, maybe looks like where they came from, grew up.
Man, that would be fun, being able to use some of these natural materials and to be able to seamlessly plug it into something that might look really high tech in conventional means.
Yeah. And there's a company I'd plug too, Terran Robotics. I've been working with them for many years. They're out in Indiana, but they're making a 3D printed cob or monolithic adobe system. Again, kind of taking that like one of those classic, more natural or hut-like building systems, and really taking technology to the next level with it and creating really impressive structures.
Right. Okay. So that's perfect segue to my next question then, Anthony. So looking ahead, whether it's AI, whether it's material science or policies or robotics, what disruptions do you think will most impact the sustainable design in, say, the next decade?
What impacts will affect sustainable design in the next decade? I'm tempted to talk about governmental policies, and carbon credits and carbon taxes, but a step down from that is building code change, and we're already seeing that. Whereas operational carbon in California, here we call it Title 24, but every state has pretty high requirements for energy use and insulation requirements. And embodied carbon, if you go back far enough in the electricity chain, the factories are getting the electricity from the same electricity manufacturer that the houses are getting it from. So and it's all because it was so much easier to legislate building code change on operational carbon, because it was so much easier to quantify. But now that we have enough data to quantify embodied carbon, it's the same carbon, it's the same energy source. And so we're seeing that happen. California just led the way in their Cal Green Code for embodied carbon limits on, it started off with very large buildings and they're scaling that down. And so building code change is important, but this continual, snowball rolling down the hill of societal awareness of climate change and the ways that you can make your own personal choices and how that affects the design community. I mean, there's very few young designers coming out of college right now who don't want to make environmentally smart buildings. And so I think just continuing to encourage that development and foster that energy in the right way.
No, I couldn't agree more. With the trend and the traction that the industry is getting, I'm excited to see it grow and flourish in time here. Okay, so some might argue that net zero it's a lofty goal, but it's not realistic at scale. Would you agree with that, or do you see that path? Do you see it making it more mainstream?
I don't agree with that. We do incredible things as a human society. technologies that didn't make sense at all, but there was drive for it because, maybe it's a source of a fossil fuel byproduct, and the fossil fuel industry needed something to do with this thing. And now we have, plastics going everywhere, this and that, where these materials aren't more expensive and not ubiquitously used because they're inefficient necessarily. It's just because there hasn't been the proprietary investment in the innovation of the materials. And once, I already used the snowball analogy, but once we're seeing that snowball starting to roll down the hill, where the building codes are changing, the ability to document embodied carbon is changing, and people's mindset and awareness of it is changing. And that allows products and companies then to innovate on the space, and designers to innovate even for the more natural systems, the site source systems, to innovate. And when that all starts happening, I'm already seeing rapid change. It wasn't that long ago that I feel like my mentors in the space were down and upset that it felt like they've spent their whole careers trying to forward straw construction, and it really felt to them like it wasn't catching on. And then there were just a few turns that happened really not that long ago, like 2020 kind of pandemic space, where all of a sudden we realized something clicked. The word had gotten out and people were looking at us. Why aren't you scaling fast enough? And so I disagree that they aren't high performing and therefore they can't scale. And we just need support. I mean, fossil fuel materials have been fossil fuel sourced materials, have been essentially subsidized for years, as the way that we subsidize oil in our country to, for reasons, and we can get into the politics around that and the importance of it and making the engine run. But we're competing against that system, that entrenched system, to get to scale. But once these materials can be at scale, and you have a factory making a insulation product like the Verdant panel, if once we can get to scale with that, we're not melting glass like fiberglass does. We're not melting rock for our insulation like rock wool does. It's an existing agricultural byproduct, but it's more difficult to get in your building simply because that tradition and trajectory was very prohibitive to that advancement previously, but that is changing now.
Right. Okay. So I love the way you're able to squash that myth. It's more about, not where we are now, but we are making progress in that direction, right? It's just a matter of time. Okay. So, Anthony, as far as growing as a company, what would you say you guys is at Verdant, what is your guys' biggest bottleneck you guys are facing right now?
Growing isn't necessarily our priority. It is an outcome of achieving other goals, like helping the clients we care about and helping people use the materials that we care about. And we have plenty of other goals as a company, being, human focused and whatnot. But from a growth standpoint, it's so smart growth is really our main idea. We don't. Right now, we're going on 20 people in the engineering firm, and the Verdant Building Products is just kicking off and is much smaller as a startup right now. But it's also not, we're licensed across the country and help people who can't find engineers who are knowledgeable on these materials, but it's not necessarily our intent to, as an engineering company, monopolize the natural building engineering space. We just want to help people be able to build low carbon, deep green systems. So what is prohibitive to growth? One thing, we would be growing faster if more people were open to these materials. There isn't a hindrance to, like every time you say you're going to build with straw, somebody brings up the Three Little Pigs, and I'll just say it outright that it's just a bad idea to have pigs building your buildings. I'm quoting one of our straw bale forefathers there,
Yeah.
Mats Merman, who recently passed away. But you're kind of, well, that stuff burns, and it's like, well, do you know that the fossil fuel materials that you make your buildings out of now also burn? We just have ways that we build fire safe assemblies with those materials. And in fact, straws, hemps, and clays are incredibly fire safe. They suppress, there's very little oxygen in the system, so they perform far better than a lot of the materials out there. But I'm still faced like every time someone's like, well, that's definitely going to burn. And we have to kind of get over that hump just because emotionally we aren't used to building buildings with these materials, and that's understandable. And so I think that prohibits is a big hindrance to growth too.
Right. No, that I can only imagine that's always a misconception. But once again, it comes down to that education piece, right? Being able to get everyone on board and eliminate some of these myths in the industry. Um, okay. So maybe you can share with us what project right now are you guys most excited or proud of, and maybe share with us a bit of framework that led to its success.
That's a great question. We have a lot of irons on the fire. It's so interesting to say. I was just at a natural building conference. I go to speaking at Green Build in November as well. We go to from the natural building conferences to the more corporate and conventional green building conferences. But I challenged that group to approach me with a material use case in this more alternative space that they think I might not have pursued a permit acquisition for, being that like anything, not just hemp straws and clays, but bamboos and even magnesium phosphate cements and other pursuits there that we could trickle down. My colleagues pursuing mycelium structural uses at Occam Works, and there's when I've reached a fun point in my career where we have straw being built in a very natural form and bale raising community, and then I have our first Verdant product. Verdant panel projects hitting the ground, getting permits, going through smooth. It's a code compliant system out the gate, feeling that happening. And at the same time, so I have, these incredibly curvilinear, really radical looking cob buildings which is a monolithic adobe, a clay form that's quite sculptural. But I'm equally as excited about that as I am in the permits we do there in high seismic zone and lower seismic zone. And, these clay and straw systems in Michigan where we're using actual saplings to create a flexible wind resisting system, a diagonal wind resisting system around a round structure. I'm equally as excited about that radical and funky stuff as I am about the most square building where we were able to really get straw to cost and to scale. And so and just nerding out on low carbon concrete mixes, calling batch plants, having that conversation with them, making sure there's not a disconnect or a misunderstanding about what we need as an engineer that would facilitate them to bring the pounds of cement per yard down. I can get a 5x, not X, but 5 degree decrease in carbon content of concrete. Concrete, the material we most know to be 8% of global greenhouse gas emissions are associated with concrete use. This is a big player in the space. And when you can decrease your carbon mix by 5 times on a project, just from a few conversations to make sure there's not a misunderstanding, that's a big deal. And that's really not that exciting to talk to somebody about at the bar, but it excites us. And, things just work every day.
No, that's awesome, and I can tell your passion definitely exudes through you and your work in this conversation. So there's absolutely nothing wrong with that, and I encourage you to keep it going.
Thank you.
Okay. But Anthony, before we wrap things up here, just a question we'd like to ask all of our guests. If you were doing what you're doing now with Verdant Engineering, what would you be doing instead?
Good question. I really liked playing my fiddle in a bluegrass band for a long time, but that time's behind me. I'm really gracious that I had the opportunity to fill what I found as a void in our field, and I think that's like as something to hope for in life is to find somewhere where you're needed, where there is need, and be able to move forward with with a project or a process that you find morally stimulating and valuable to you and your community. So I'm not sure what else I would be doing. Uh, I'll save your listeners the tangent on, pursuing farming or something. But I am very grateful that I'm able to be in this position right now, work with the wonderful colleagues here at Verdant and beyond, our clients that we work with every day.
Well, I'm glad that you were able to find your calling, and the industry has someone like yourself leading the pack. Um, Anthony, before we close, where can people find you and Verdant Structural Engineers, and perhaps maybe you can leave our listeners with one actionable challenge that they can act on this week to move closer to net zero in their own work.
Yeah, good question. You can find us at verdantstructural.com, VERDANT structural.com. And my email address is anthony@verdantstructural.com. Please reach out. The Verdant panel, Verdant Building Products, is at verdantpanel.com. But you can also get there from the Structures website. And I would challenge people to be open and look into these materials and look up to see if there are neighbors you have or designers in your community that are using them. Go take a look at them. A lot of these natural building systems are like really nice to be in, to feel the acoustic wise, and they don't have to, but they can give off a real pleasant feel, and they're worth experiencing and considering. So thanks for listening, everybody. Thanks for having me, Jordan.
No, it's an absolute pleasure and privilege to have you here, Anthony. I'll be sure to highlight your socials and your website on our notes below. But it's been an incredible conversation. We've been able to unpack a bunch of myths around sustainable design. Explored some frameworks for carbon neutrality and looked ahead at some possible disruptions shaping the future. But for our listeners, the key takeaway is this: don't wait for perfect conditions. Start embedding sustainability into your projects now. Anthony, thank you so much for sharing a ton of wisdom with us today. Now, if you guys have enjoyed today's episode, make sure to check us out at advisораisolutions.com or on our Instagram at advisorai.solutions. And of course, don't forget to like, subscribe, and share this podcast with someone who needs to hear it. And until next time, automate the ordinary and scale the extraordinary, everyone. Bye for now.